to all the participants. I welcome you all in today's session about emerging technologies, artificial intelligence, and machine learning. Today's session is all about artificial intelligence and machine learning, which are emerging technologies for today's era. So, without wasting much time, here I would like to welcome our today's speaker, Miss Maria Johar, on behalf of Parul Polytechnic Institute, Parul University. Welcome, ma'am. To give a quick introduction about her, I would like to say that by qualifications, she holds bachelor's and master's in computer engineering with specialization in data science and artificial intelligence. She is also gold medalist and topper all throughout the academics. She also held 11th position at Grace Hopper's conference Artificial Intelligence National Hackathon 2019 and a data enthusiast. She has been working as a senior data scientist at RWS Moravia for 2.5 years. She also holding a strong software development background in the past work positions. She is currently work on various AI domains like conversational AI, chatbot development, automation workflow, machine learning and deep learning modeling based on the latest technologies like Python and R programming. So she is also passionate about shaping the young minds, feeding their curiosity with aptitude guidance and equipping them with technological skill. She have firm faith in transforming lives with motivational thoughts and moving them towards an optimistic approach for life. So now we are ready to start our session. Over to you, ma'am.
Thank you so much, Fatima ma'am, for such a warm welcome. And I would like to thank Hutesh sir for inviting me over for this session. So let's start. So today's topic is about the emerging technologies, that is artificial intelligence and machine learning. So these are the buzzwords of the industry these days. And if we go ahead and see what is this AI? So by definition, it is concerned with the design of intelligence in an artificial device. Whenever we impart intelligence in an artificial device to perform intelligent tasks is known as AI. Now, if I talk about the intelligent tasks, what do we expect out of it? So we expect something to perform like a human, because human is the only entity that is intelligent, right? So there is always a what we say, that there is a controversy between understanding of AI and a robot. So what is a robot? So robots are programmable machines that can autonomously or semi-autonomously carry out a task. So robots are basically programmed entities. They don't have their own any intelligence. They are programmed to perform a particular task. So looking ahead, what is the difference between an artificially intelligent device and a robot? So an AI device is programmed to think. Now, thinking is the ability of a human. When they have data around, when they have situations around, so they perceive the data and then perform in a particular direction, depending upon their understanding about the situation. They see that there is a danger around, so they run. They know that there is a hot object around, they don't touch that object. So that is an intelligent task. And robots does not have that ability to perceive the surrounding. They are programmed to perform a particular task. So they are programmed to do a particular action. Then we have that AI has a social interaction. Now, if I talk about the social interaction, then we all know that there are devices coming up that are actually talking to the humans, the AI devices. We all know about the Alexa. What is Alexa? It is conversational AI in which we can talk to the device and the device gives us the answer and talks to us. So that is a social interaction we can interact with AI and AI devices. But in case of robot, the humans can only have a low level interaction. Now, if I say that low level interaction, what does that mean? That means their hardware is programmed to perform a particular task, right? And then AI learns. Now, what is learning? Learning is we provide it with the data, and based on the data, they gain knowledge out of it. They learn through the data and the trends, and then understand how to perform, right? And in the case of robot, they're only smart as programs. Smart as programs means we have programmed to perform a particular function. So that's what is the role of the robot. Moving ahead, how do we define intelligence? So by dictionary, the definition is the faculty of understanding. The faculty of understanding. Understanding the situations and the conditions around, the human takes up a particular decision. In a similar way, when we feed the AI device with the data, the device understands the data and the data trends and then take a particular action. That's what intelligent means in AI, right? So an intelligent machine can complete a task in the presence of an unreliable and dynamic working environment. The data is not constant, it is ever changing. And so is the situations around us, right? We are comparing, all through my presentation, we'll be comparing a human with an AI device. So in case of humans, we have ever changing situations around. The conditions are ever changing. And we have to take up a decision depending on the most optimum solution, right? Based on the situation around. We choose depending on the risk. So that is how an AI device is programmed to pick up the most optimum solution given a situation. So when the device is able to perform in an unreliable and a dynamic in the ever changing data environment and is able to take up a decision and a correct decision, then we say that this is the intelligent device. Moving ahead, we talked about the understanding. The faculty of understanding is intelligence. Now, what is understanding? So, to comprehend something or to recognize its significance. Whenever we have the situation around, whenever we analyze it, right? Whenever we analyze it and then try to understand, to calculate a risk matrix in a normal human environment. So that is what understanding is. How you understand the situation. And based on that, you take up a decision. And how good decision you take decides how intelligent you are. I hope that's clear. Understanding about the situation and then taking up a stand. or choosing up a path, depending on the risk matrix. So how intelligently you pick up the solution, or how intelligently you behave in a particular situation, defines your intelligence in a human environment. And on a similar note is the AI. How intelligent is the AI device? How much data we have fed, and how it is able to perceive the data or understand the data. And based on the understanding of the data, how it is intelligently able to take a particular action. So that is all about understanding. I hope that's clear. So this particular figure sums up the intelligence and the understanding. So we have the knowledge. The knowledge is the data. And the data, the understanding basically of the data is the knowledge. The understanding of the data is the knowledge. Okay. And after having the knowledge and perceiving the situation or the conditions around, whenever we take a particular decision, and that decision making is all dependent on how intelligent the device is, right? So once a decision has been made, depending on the intelligence, the device takes up an action. And it is very, very similar to a working of a human. We have the knowledge like we read up stuffs, we gain knowledge out of it, we extract the understanding out of it. What are the main points and skim off the irrelevant things. And after understanding how intelligently we behave, after having that knowledge, and then we take up a decision. So it is a very, very similar thing, a human environment and an AI environment, and how they behave. Moving ahead, so what are the main AI approaches? There can be various processes. One is the top-down knowledge representation. The second is the bottom-up machine learning. But to conclude it, there is machine learning and deep learning that helps us achieve artificially intelligent system. And these are something the buzzwords of the industry. We have been talking about the AI, the machine learning, and the deep learning. So let's try to understand what is all this about. So you see this figure in which the outermost layer is about the artificial intelligence, and the inner circles are talking about the machine learning and the deep learning. So AI is the major part in which it encompasses machine learning and the deep learning. So these are the two things that enable us to make an device intelligent. So that helps us in constructing an AI device. Now, what is basically machine learning? So it is a subfield that actually relies on numerical optimization and statistical approaches. So that's what we do in a machine learning algorithm. We have the data, we apply some high order derivatives and some mathematical equations to derive a conclusion. That's how machine learning algorithm works. So there are three main types of learning. One is the supervised learning, second is the unsupervised learning, and then we have the reinforcement learning. So in supervised learning, what we have is basically we have a data that is labeled data. Like we have a particular pattern given in the form of input, and we have a corresponding output to it labeled. We provide that particular data to machine. Like if this particular pattern is coming, then label it as this, right? So if I say that a particular person entering a bank with all face covered with a black mask, not that mask which we are using during the COVID, but the whole mask that thieves use to cover themselves so that they can escape to the police. So if that particular face is identified, then it might be an alarm to figure out a thief. So this particular type of patterns with a labeled thing that this type of human is coming with a covered whole black mask, then we can label it as a threat. Not directly as a thief, but we can figure it out as a threat. It might be a threat. So this type of data when we provide our machine, it's called a supervised data. And this type of learning when we provide to the machine, it's called a supervised learning. Moving ahead to the unsupervised learning, in this case, we don't have a label data. We have just the trends, and then based on the action that the model performs, it learns continuously and figures out if this particular is the label. Right? So we have an unlabeled data, and we figure out similarity between the data, and we cluster them. That this particular type of data trends belong to a particular class or a particular label, and the other pattern belong to a different label or a different class or a different category. If I'm using a class or label, so basically it means a category. Okay. Then we have the reinforcement learning. So in reinforcement learning, the model learns based on the instructor that actually gives a reward or a punishment. If the model is able to interpret right, then it is given a reward, and if not, then a punishment. In this case, reward and punishment are some mathematical weights that we give to a model, to a mathematical model, right? But for an understanding, we are using such terms as a reward or a punishment. So in that kind of scene, we call it as a reinforcement learning. Moving ahead, so the basic task that a machine learning algorithm performs is the classification, clustering, and the prediction. We have already talked about classification, like a particular human that we talked about, and tagging it as a threat. That comes under the classification. Then we have the clustering that we talked in the unsupervised data and the unsupervised learning, in which we don't have a particular label or a category, but we try to cluster out. in a big set of data, we divide the whole lot of data into different clusters. That this particular cluster is belonging to a particular data category. Then we have the prediction. Depending on the trends, or we say that the data we have, we actually predict the outcome. Outcome can also be a number. Like in case if I give an example, then the prediction of the housing price. So a lot many factors depend in identifying the price of the house. How many floors you have, how many bathrooms you have, what is the neighborhood, how many rooms you have, kitchen, ventilation, right? So all these factors depend on the price of the house. So even AI model can predict that. Given that we have certain features, like I talked about the number of floors, the number of bathrooms, and whatever features that decide the rate of the house. I think that's clear. So yes, we have another examples of categorizing or classifying the data. We have a particular data and we check out how the data is about. Like if we have a lot many news articles and we classify it into a sports category, a commercial category, or a data news that's talking about the agriculture, right? So this comes under the classification where we have defined categories. It's a defined category, and that's what we call it as a part of classification. While in case of clustering, we don't have a defined category. Rather, we draw patterns in a lot chunk of data, and we just say that this particular piece of data among the whole lot of data belong to a particular category, right? So whole lot of data is divided into different chunks to identify as a individual category. And then in prediction, we talked about the housing prices. So that's how it works. Moving ahead to the deep learning algorithm. Now, deep learning algorithm is the fastest and one of the most accurate algorithm. How the deep learning algorithm works, let me tell you. It works analogous to human brain. How a human brain works? Based on the stimulus, the neurons pass on the data from one neuron to another. Right. And on a similar note, we have the deep learning algorithm. In the deep learning algorithm, we have the data, and the data is passed on from each node to another. In the figure, you can see that each particular layer has a node, has nodes, sorry. The first layer is of green color, where we have 3 nodes. We can compare this to the human brain, where each node is a neuron. And we receive a stimulus, and depending on the voltage, there's a transfer of the stimulus from one neuron to another neuron, depending on the threshold. That's in the human brain. And on a similar note, in deep learning algorithm, when a particular data is received on a node, we use the optimization algorithm on the activation function. The activation function decides the threshold. And after a threshold is met, the data is transferred to next node. Like from the first green node to another red node. And then from red node to blue node. And blue node to green node. In a very simplified way, if we see, so there is a transfer of data from the first green layer, which is the input layer, to the last output layer, which is also green in color, here in the figure. So depending on the threshold, the data is transferred from one layer to another. Right? And how does the learning take place? So the learning take place in the backward propagation. Once the data reaches from the first layer to the last layer, and it comes back to the input layer. So at each and every layer, we check the weights. Like what is the amount of the change in the weights that's observed. That's the data loss. And we basically try to tune them to reach a particular optimum loss or minimum loss. So we have to minimize the loss in terms of output. That is how a deep learning algorithm works. Moving ahead, as I talked, each layer has particular number of neurons, and the data transfers from one layer to another layer. Right. And similar to other machine learning models, we talked about three types of problems there: the classification, the clustering, and the prediction. In a similar way, the deep learning algorithm functions. So there are particularly two main deep learning neural networks algorithms. One is the CNN, that is the convolutional neural network, and the second one is the recurrent neural network. So in convolutional neural network, it generally processes the images. So when we evaluate the images, we use CNNs. And if I give you an example of a CNN, of a convolutional neural network, so we can take a simple example of classifying a particular image into various categories of flower. So I train my machine learning model on a whole lot of flower images. And that particular data is labeled. Like 100 images of rose, 100 images of sunflower, 100 images of daisies, and so on. We train the model with that data. And whenever a test image comes, so my model behaves intelligent enough to identify the category of the flower. So that is how CNN works. It takes out the features from the images, the main features, and then passes on to the next layer and identifies a particular label. That's how CNN works. While in case of RNN, we have a particular text data. And each particular token is identified to make a prediction for the next token in the sentence or the text stream. That's what RNNs are useful for text prediction, for the future prediction of the sequences. Right. Now, if we talk about the task domains of AI, what are the main task domains? So there are three main identifiable task domains. First is the mundane task, second is the formal task, and the third is the expert task. Now, what are the mundane tasks? Perception of the data, what it is. Second, vision, who it is. Right, identification. Then speech, we are talking to the Alexa, speech identification. Natural language understanding, whatever we are writing or whatever text is available in the book, if my AI device is able to read that and understand it and take out the knowledge out of it and then use it to behave intelligently, then we say it is a mundane task of AI. Then we have the generation. Whenever we have a data pattern, there is one kind of problem in which we generate the pattern. So that comes under the generation. If I give you an example, if I have a topic is sports, and particularly in sports, if it is table tennis. So if my AI is made so intelligent that it understands the topic first, the table tennis, and then writes a particular article on it. So that comes under the generation. And this is the most intelligent task. And AI machines are able to achieve that today. Then we have the translation. Now, we have manual translators in the form of humans. Similarly, we have the AI devices trained in such a way that they can translate it from one language to another. So that also comes under the mundane task. Then the common sense. It is still unachievable. But scientists are working on it. Then the reasoning. How did you take up an action? Like, how did you perceive the surroundings and then took a particular action? So that reasoning is also one of the hardest tasks. Moving ahead, we have the formal tasks. So we have the games, the computer games that we play with. That's a kind of, we say, intelligent task, right? We have the mathematics task in which we give certain parameters and the machine calculates it and gives us an output. So these kind of tasks are known as a formal task. Then we have the expert task in which the machine performs accurate and as an expert. Like we have the medical diagnosis. So there are diagnostic systems that have come up that actually identifies the history of the patient and suggest a particular line of treatment. So that is what medical diagnosis is. We even have the robotic surgery, right? So the robots are trained in such a way that it can perform a particular surgery in the most exact way. So that's an expert task. Then we have the engineering design, the financial planning, the scientific analysis. All the expert tasks come under this category. Now, if I say what is easy and what's hard, so basically, it has been easier to mechanize many of the high level tasks, meaning that to perform like an expert, it is easy. It is easy to basically devise a device that performs in a static environment and achieve a particular task. Right, given a particular set of situations, if that's fixed and the machine is trained to achieve that, so it is easier to conquer that. While it has been very hard to mechanize the task like human, in which the machine behaves as intelligent as human. All the human activities, to mimic those, are tough. Given the example that walking around and without running into things. So this is a hard thing. A lot many perceptions are required in that. First, sensing, visual with the use of vision. You need to identify how far is the object and in how much time you will reach near to that. So that you need to take a turn, not to run into that object, right? So whenever you try to train the machine to behave like a human, is a tough task. Moving ahead, talking about more applications. So we have the manufacturing robots, working in the manufacturing industry, and the self-driving cars. How does that work? Identification of the traffic, the object, the car in front of it, calculating the distance, right? And then managing the speed according to that. In fact, even identifying the traffic signals or other board signs, and then taking up an action based on that. That's how self-driving cars work. Smart assistants, Siri, Alexa are an example of that. They're trained on a whole lot of data to give out an output. Then the proactive healthcare management, depending on the data, patient data, take up a decision. Disease mapping. When the COVID came up, there were a lot many scientists who worked on those chest CT scans to identify the severity of the COVID. That's how disease mapping works. then the conversational marketing bot. There are the smart assistants for ordering a particular item. So in few countries, there has been introduced by Pizza Hut, the ordering system based on the conversational AI. They identify what the human is trying to say and what they mean to order, and then completing their transaction by delivering the pizza. So that's how the conversational AI works in the field of particular industry. Then we have the natural language processing. We talked about the extraction of knowledge out of the textbook, reading a whole lot of data, and then taking out the main points out of it and gain knowledge through it based on the understanding. So that comes under the natural language processing. Each and every human has their own way to talk, to frame the sentences. So that's another challenge, NLP. And we have certain tools for NLP. So building of those tools to ease the processing of natural language is a part of application of AI. Now that we have moved to the end of the session, I would like to give some motivation tips to the audience watching this. Whenever we plan to achieve something, we define an aim. It's not easy to climb up the ladder of success. On the first rung, you see a devil of fear. And that fear is nothing tangible, but it is all cooked up in your head. It's all man-made. And that's all what you have made. So that first rung, climbing the first rung, is a tough task because the devil of fear is standing there. Fear about the failure, right? The fear of failure stops a person to climb the ladder. And that's what you need to overcome, your own thoughts of fear. And I always pick up the example of Thomas Alva Edison, who failed 1,000 times for building the electric bulb. And he was never ashamed about his failure. He never stopped. He kept on working. And then one fine day, the discovery happened. On a similar note, if I talk about myself, 3 years back, when I was working on my research, I failed many times, and I'm not ashamed of it. I was also going through many personal things, but I had that stubbornness to achieve my goal. My model started with 52% of accuracy, but I worked day and night to make it accurate to 97%. I feared my failure, but still, that stubbornness overcome my fear. That stubbornness to achieve. So I would advise each and everyone watching this. Keep your milestone in your head. Keep smaller milestones. Keep on achieving them and strike off them off the milestone list. That's very satisfactory. Don't fear. Just keep on going. What if you fail? You're back to the wrong one. But what if you reached the highest point? Don't fear. Overcome it. And that's where I end my session. Thank you.
Mariam, we are having some few questions, whatever you believe we talk. Okay. Ma'am, the question is that we are having different computer languages like C, C++, Java. Okay. So in AI, which languages we are using to develop the programs?
We generally use Python and R. So in industry, Python is more famous and we use Python more. So if someone is trying to work on machine learning and AI, then get your hands on over Python.
Okay. Ma'am, there is another question that you have mentioned that about the deep learning and the machine learning. Okay. So, what is the difference between that, like machine learning and the deep learning?
Deep learning is a part of machine learning. It is as we talked about, the deep learning functions as a human brain. It is a part of machine learning. But it is a more accurate way of, of achieving machine learning. In machine learning, you have the simple mathematical algorithms. But in deep learning, you have the models that imitate the human brain and the functioning of the human brain. It is not a statistical function or a linear algorithm. No. It is a whole lot of model inculcating many algorithms in it. I hope that answers.
Yeah. Ma'am, another question is that you have mentioned in your profile also in your presentation also that chatbots. Can you elaborate to our student what is the chatbots means?
Yeah. So as I talked about the conversational AI, the chatbots. So in that, basically, you talk to the AI system that behaves as intelligent as a human, that actually understands what you're trying to say and carry out a particular conversation. So a chatting robot is a chatbot, right? And the answers coming from the robot is not something mechanized, but it is able to understand what the human is trying to say, understand that based on the knowledge that it is taught and the understanding, it gives out a particular answer. So as I talked about the chatbot for pizza delivery, that's already up in other countries. So what does that do? We talk to it and we talk in the human way. We don't say in a normal way that I want to order this. There are certain other ways also in which the human can say, you speak in a different manner, I speak in a different manner. Everyone has their own way of defining the sentences. So that's how the chatbots work. They understand what the human is trying to say and then gives out a response.
Yeah.
Okay.
Ma'am, Fatima, that is another question related to game. Like how we can relate the game theory with the AI.
Okay, that's a good question. If I talk about the chess, right, so there are all possible steps that can be taken by a particular object in the chessboard. That's defined already. The machine is trained on those particular steps. And if that particular steps come from the opponent, how the machine has to behave. If there is a threat to the king, right, threat to the pawn. So in what direction to move? That's the part of intelligence based on the knowledge, right? So it's trained on all the various possible steps that a particular object of the chess piece can take and how to behave in case of each and every move of the opponent. So that's how games work. Training it with all the possible combination of steps and then giving out a particular action.
uh, there is another question like for the application purpose, like some of the people we are having the application like Facebook, WhatsApp, Instagram. Okay, in some of there they are using the face recognition. Okay, so how this face recognition which they are using, so that will be in AI, how they are using face recognition instead for Facebook or Instagram or another applications.
That's a good question. It comes under the AI, biometrics, the hottest word we are using for even the unlocking of the phones, right? And the unlocking of the apps. So basically, it identifies the facial features of the human, and then stores it in the database. That if this particular trend, this particular facial feature is identified, then it belongs to this particular person. So we have like a big data because millions of users are using these particular social media apps. So we have the facial features of all the users stored in the master data. And based on that, on the recognition of the facial features, we identify the person. That's how it works. And we store the principal components. The principal components means the identifiable and the most prominent features of the human face. So yeah, that's how biometrics or the facial recognition works.
Okay, ma'am. One last question that there are the many fraud detection fraud cases are going on. Okay, like somewhere we whatever the application we are using. So how we can use AI to the detection of the frauds?
Okay, that's a good thing. As I talked about first example, in case of the bank Bulgarily, right? So in that case, if we talk about the fraud analysis, we can tap the IP addresses. From which IP address the request is coming. And there are certain flagged IPs, right? If the request is coming from the flagged IP, then we can mark it as a threat or mark it that this particular request is a fraud request. So there are a lot many proxies that people use to bug this. But the anti-fraud department or the cyber department of a particular company takes care of tapping those requests, those IP addresses, from where the request is coming, which country, and which system basically. If this is a particular valid IP or not, or if it's a proxy. So it stops. That's how it works.
Okay. Ma'am, one last question from my side. This is personal question from my side, that how we can use machine learning in that blockchain thing.
Ma'am, actually, I have not worked on blockchain. So
Okay.
I think, yeah, I won't be able to answer that question.
Okay, fine, ma'am. No issue. Okay, so I think students get the whole idea about artificial intelligence and machine learning and also how it works. So thank you so much for your valuable time, ma'am. Also, I would like to thank our principal sir, Professor Jatin Vaidya, to provide endless support and motivation to take such a kind of initiative. And last but not the least, thanks to all our participants. Thank you so much.
Thank you so much, ma'am.
Thank you, sir. Thank you, team, for inviting me over.
Welcome.
Okay, welcome, ma'am.